Blimey, a dingo ate my baby!
Crikey, a dingo ate his baby. Yeah, I'll worry about that later. G'day, I'm Steve Irwin and I'm the once in a while hunter. But today, I'm the galvanic pile hunter. In today's adventure, we're going to be exploring the riveting world of household wiring. Now, where I'm walking, there's a potential underground wire. I'm now crawling on a potential underground wire. Now I'm running. Now I'm swimming in a potential underground wire.
Oppan Gangnam Style!
Alright, mates, now before we get on to the hands-on experience, we're going to look at the fundamentals of household wiring. Now on the left-hand side, you see the wires that come from the electric company and go into the transformer, which then are transformed into the hot 1, hot 2, and the return neutral wire that goes to each of the houses. So here we have the transformer. The main power line comes underground from the power company into here, which then feeds off into the surrounding houses. My humble abode is over there, so let's go check it out. Woohoo! Now that was exciting. So here we have the electric meter. The hot 1, the hot 2, and the neutral wires come from the transformer underground in parallel and go up this here too. These wires go into the electric meter before they go into the house. Once it's done gauging the electricity, it goes back through this vessel and into the circuit breaker. Let's go have a go at it. Okay, so here we have the main circuit breaker. Now our circuit breaker is added in series, unlike everything else which is added in parallel. That way you can shut off the entire system if it overheats or the current gets too strong, instead of just one circuit. So the vessel from our side comes up here and goes into there and feeds off into individual circuit breakers. There's the main circuit breaker. Then it goes up here and splits into multiple wires. When the hot 1 and hot 2 get put together, they make a 240 volt wire. When hot and neutral are put together, it makes a 120 volt wire, which are the skinnier ones. Both of these go up into the house. Then moving down here, we have the 2 ground wires. These both make it so hazardous voltages won't be accumulated. Here's a diagram of a household circuit breaker system. Now, my house personally has 19 different circuits, but this basically shows what it looks like. There are also fuses which can do the same job as a circuit breaker, but they are kind of inefficient because every time they detect unnecessary amount of current, they have to be replaced. Now over there is a 120 volt outlet. It is quite a fascinating spectacle. Let's go have a look. Right, here we have a normal household wire. Black is the hot wire, white is the neutral wire, and the copper is the ground wire. Now this goes into the 120 volt outlet. The smaller one is the hot, the bigger one is the neutral wire, and the middle one is the ground wire. All circuits in the house supply alternating current, but most devices use direct current. When that happens, you need an AC adapter to convert the alternating current into direct current. Now, ahead of me is the highly venomous AC adapter. Now I'm gonna attempt to wrestle this. Here we go. Woo, crikey, oh, he's not. Oh. Alright, now I'm gonna plug this behemoth in. There we go. Very nice. When wiring a house, you can easily make it so two switches control the same light bulb. This is that example. It's called a three-way switch. Here's another modern marvel in the world of electric engineering, the ground fault circuit interrupter.